So we've got Nirupam Sarkar from Fidelity Investments. He is VP of Data Science, and he's a vastly experienced data and imaging scientist. From starting as a team leader at Ramco Systems in Chennai, he has since, amongst other positions, held consultancy roles at LexisNexis and Procter & Gamble, L3 Communications, and Analogic. And he's now, as I said, VP of Data Science at Fidelity Investments. Our other guest is Brian Olsini. Please say your name. You just told. Ulisny. All right. I'm really good at names, as you guys all can tell, right? So Brian is Senior Technical Scientist at Raytheon Technologies. I used to be United Technologies before it merged. He's a Senior Technical Scientist. He prides himself on his ability to identify and deliver new capabilities to serve customers based on emerging technology. So very relevant to what we're going to be talking about. Prior to his current role, Brian was VP at Thomson Reuters, where he managed the largest and oldest of 5 labs worldwide focused on customer-driven innovation based on agile data science, AI, and ML. Great to have you. So I'll ask Nirupam to start off. Please add anything else to your introduction and give some opening remarks, followed by Brian.
Basically, I worked in different companies, and many companies, I joined as a computer vision engineer or lead, where things were done manually before. So, for example, in your medical imaging industry, initially, in 2006, even 2006-7 timeframe, you have the chest X-ray, and radiologist would find out whether there is a nodule, lung cancer, or something like that. So there, of course, it is time consuming. Instead of that, we had some computer vision software or routines so that we at least can, with 80 to 90% accuracy, we can figure out that whether this particular chest X-ray doesn't have anything. So that way, a radiologist can spend more time on the real one instead of scanning through all unnecessary one. And of course, after that, I joined many companies where things were done manually, we added machine vision, computer vision capability to it to enhance the operation. Anyway.
Great, yeah, thanks. Just to back up a little bit. So I'm actually with Raytheon BBN. So BBN is a subsidiary of Raytheon, the huge defense giant. And BBN's been a research company for 70 plus years. So we were spun out of MIT, originally doing acoustical engineering. So they, one of the first things they did was design the acoustics of the UN General Assembly Hall in New York, and went from there to do all kinds of interesting and groundbreaking research, including in natural language processing and machine translation and computer vision. And today we do everything from speech and language technologies to quantum computing to synthetic biology and applications of cybersecurity to synthetic biology, detecting whether someone is sending something that shouldn't be synthesized to a synthetic biology facility and things like that. So I'm currently the Associate Director of Research there. We're interested in computer vision in a lot of different ways. So we've done a lot of projects in both surveilling, automatically surveilling things like we've done projects for the government and commercial sponsors as well, where we, for example, were looking at examining railroad tracks, doing surveillance of railroad track health while traveling, at 40 miles plus per hour. We do a lot of stuff with understanding what military training exercises, in particular medical military activities. So watching what medics are doing in the field and trying to understand what they're doing and help them to check all the boxes, do things correctly, in an automated way. And then, of course, we have BBN is a subsidiary, in particular, of Raytheon Intelligence and Space. So we've got more and more, satellite imagery and so on, and all of that needs to be processed and analyzed as quickly as possible, and then there's more and more of it. And one thing that there was an interesting article in The Economist this past summer that pointed out that, satellite imagery used to be very tightly held, that only governments had access to it. And so they could kind of, analyze it on their own time frames and didn't really need to reveal what was going on to anyone until they felt the need to do that. But now with the democratization of satellite imagery, you have everyone in this room has access to, Planet Labs, constellations of satellites, for example, that image the world once a day. The ability to sort of hide what's going on in some part of the world and only sort of give the government's perspective on it when they feel like doing that is no longer possible. All sorts of people are able to analyze in real time, and we're seeing that with the Ukraine war, for example, what's going on in all parts of the world. And so, being able to throw enough intelligence analysts and imagery analysts at this problem for the government to stay ahead the way they used to be able to is no longer possible. And so more and more we need AI-based solutions, machine learning-based solutions to understand what's going on in overhead imagery in particular. My background in particular is in computational linguistics. So you might think, well, I'm in the wrong room here, but we're, in particular, really interested in this emerging class of language and vision models. So jointly training language and models on both paired texts and the images that go with them and so on has just, proven to be a very, very exciting area, and we're recently starting a program to, leverage computer and language models, joint models, to help do satellite imagery analysis and speed that process up. So there's all kinds of really interesting things going on that BBN is trying to participate in through our government partners. We primarily work with agencies like DARPA and the intelligence community and so on. So we're a little bit further out from productizing than I was in my past lives when I was working at Thomson Reuters, and we tried to deploy, and we would deploy vision-based products within, a year's time. So things like doing trademark image search for lawyers in a visual way was one thing that we were able to roll out in a pretty short time frame.
All right. Thank you very much. That was great. So let me start with this, right? So both of you mentioned a few things there, right? You sort of painted a good picture of the tech that you have in the application space, right? So let me start with some very basic fundamentals. So paint a picture on, and I'm asking both of you one by one, so maybe Brian, you can start, of your workflow. So you mentioned satellite imagery, and you mentioned using both linguistics and visual side to extract some information, right? So can you walk us through this pipeline, and then following that, what I'm going to ask you is to actually correlate that to business, but let's start with that and give us an idea.
Yeah, so so currently, in a research company like BBN, business means getting programs from the government. So a lot of what we need to be able to do is be up to date with the most current research to be able to say, we believe, you're asking for something that has never been done before. We need to provide this feasibility pitch to say, based on the current research, even though no one's put things together in this way, we think we can make a convincing case that if you give us this funding, we'll be able to produce a solution. That's very much in contrast to my prior commercial work where getting to the stage of something being feasible and getting some accuracy results that were kind of impressive, that was really only the beginning of the process. And finding out what an actual solution was that someone would be willing to pay for and use in their workflow as for example, a trademark lawyer. That's, finding out all of those details about how the product would actually be used and demonstrating that it's actually usable to solve those problems. It doesn't just meet some accuracy benchmark, but is usable as a whole solution. That was, the hardest part of what we were doing.
Thank you.
I can, like all of you remember 9/11. After 9/11, suddenly the airport security has changed drastically. Like there were all CT machines, scanners, and everywhere. But there were very few people. They could they could write software to analyze those say baggages or something like that. So somebody has to see these see the X-ray and figure out, okay, there could be some explosive gel or something like that. So then the company, like Analogic, they started investing on people like us, who has a background in computer vision, so that we can analyze those images and figure out whether they are benign or might have a possibility of having some kind of explosive in it. So you can imagine that usually, like normally, in a normal situation, probably 1 in 1,000 bags could have some explosive. So that means like you are like the security personnel is going through 1,000 bags, and only one of them may be having something suspicious. But if a computer vision program can figure out with little bit error, maybe we can find 2 of these bags having some suspicious thing, the security personnel doesn't have to go through all 998 bags. So that is a huge jump in their productivity. These are the very small things that aviation security took up to improve the passengers' safety as well as the movement or throughput. Say, for example, even like if you notice that like in 2013-14 time frame, like when you go through the the baggage screening area or security screening area, you have to take out your laptop and put into another tray. Both of them will go separately, and you have to wait for quite some time. Everything will be checked and then go through it. But nowadays, you see that they are done in a CT machine in 3D image processing, and you get everything done in split up seconds.
Okay. Let me move to audience and see if anyone has any questions or comments. Yeah. Was it the lunch? What happened? All right. You do? All right. Can we get another mic?
Hello. So I wanted to understand, in especially with vision-based models for businesses, how do you deal with false positives and false negatives? In for example, the example that you mentioned where it's very sensitive as to they have to figure it out.
Yes. I talked about some medical imaging as well as this one. Of course, like we cannot be 100% perfect, but we try to err at the side of caution. Like in baggage imaging, like we can attain a 95% accuracy, but with say like 5% positive, like 5% false positive. But but if I let like 1 in 2,000 bag with a bomb to go in, that will be a disaster. We cannot do that. So we can fine tune our algorithm so that we have at least 99.5 accuracy, but doing that, instead of 5% like false positive, our false positive become 15% or 10%. So that means we have to check little more baggages either by seeing the city images or in what situation that's like opening the bag. But we always are at the side of caution so that no wrong thing goes in.
Yeah, so I think it depends really too on the use cases. This is where the user experience is primarily a business decision, and it depends on the use case. So, for example, I have one of these Ring cameras on my front yard, and it reliably detects humans, but it also reliably says, gives me an alert when there's wild turkeys in my front yard, and says there's a person at your front door, right? Now, so if we said no errors like that are tolerable, then obviously there would they wouldn't have released that product. But in that use case, I don't care that occasionally it shows me turkeys. In fact, I kind of like seeing the turkeys, and I don't mind that it labels them as people. So it's, those kinds of trade-offs are really business decisions, and really depend on if this were screening for cancer or something, that would be an entirely different, or screening for suspicious packages in an airport. But yeah, turkeys as people, that's okay.
That's how we know we're in Boston when you see wild turkeys in your backyard.
Yeah,
Or
but
front yard.
you cannot shoot them. You have to use bow and arrow, unfortunately.
All right, no animals were harmed in the making of this, all right? But I think on a serious note, right, so precision recall, classical classification algorithms, you have to manage that, right? It's a lot of times it's difficult for you to increase both. So I think what our esteemed guests are really saying is that, hey, depending on your use case, whether are you okay with having additional false positive or you're okay with having additional false negatives, right? In the case of the security stuff, you do not really want false negatives.
Yeah.
And if it is also a medical example, you don't want false negatives either. So, and I think there is literature filled with a bunch of these examples, especially in early days of classification, where you would get some like 90% accurate algorithms, and it would not still work because you do not want to miss that 10% chance of detecting a disease that you want to catch early on, right? So let me pivot a little bit right here to, let's talk about business metrics, right? I think this is important. So we've talked about a bunch of these examples. Brian, you've given us sort of also the satellite, and that's one of my areas, so I keep going back to it. Tell us how that translates into value. Like, why would anyone want to deploy this? Why wouldn't you just hire, and I'm going to use your security, baggage security example. Why don't you just hire more and more people? Or why don't you just open up every bag? I mean, yes, there is a trivial answer to say cost, but what are the metrics that actually matter? Can we try to dig deeper into it and see where that is at?
It's basically reality of, I'm sorry.
We'll use your button.
It's basically the reality of the positive event. Say for any lung cancer, when you scan through, probably the probability is 1 in, not exactly even probability, it's 1 in 1,000 people can have lung cancer. So that means having more people, for that, in USA there is not enough radiologists to go through all the images, all the chest X-rays. So they don't have the bandwidth. So you have to have some capability, you have to have radiologists to go through those X-rays. We don't have that many radiologists. That is one thing. But when you have 1 in 1,000 might have, would have this situation, and rest 99, even 999, even if you just ignore that 990 of 8, it's a huge improvement from from your economic perspective. Like you can have less number of radiologists, and they don't have to break their back doing their regular work.
Okay. Brian?
Yeah, I mean, there's lots of things to say about the economics of delivering these kinds of systems, but in addition to the cost of people versus machines, there's the fact that, the machines then can retain the knowledge that is somewhat transient in humans. And so, we've seen, for example, with GPT-3, that's a model that's increasingly getting more and more powerful because it's being constantly retrained, and so that's a model that can't be really duplicated just by throwing a huge number of people at it. It's actually exceeds the kind of economics of scale of just throwing bodies at a problem. And so we're hoping for the same things with satellite imagery.
So I think what you both have alluded to, right, is it's not necessarily just only cost as the bottom line. There's backlog issues. You want to speed up utilization, you want to speed up time from getting a result. And as well as I think what you alluded with the satellite imagery is that you can only have so many people that will want to go and look at each and every one of those. And it takes a certain level of training to decipher that imagery that you can also have built into your machine learning models, your computer vision models, or hybrid linguistic or vision models. And that sort of thing helps, adds value that can then translate into some economic metrics which relate to the business itself. So let me go back to the audience, and I see a couple of hands raised, so that's good. Where's the mic? Tim keeps running out of the room, so when he comes back, just lock the door behind him.
Hi. So I have basically two questions. I'll just ask you. So times and often we have seen that various techniques which have been applied to natural language processing, and those techniques finally being reflected in computer vision, and they perform really well. So why is it like techniques being applied in one particular field is being transferred over to another field? Why can't there be like a general technique which can apply to both NLP as well as computer vision? That is one part of the question. And second part of the question is completely unrelated, but since you were talking about, like Brian was talking about satellite imagery, so basically if you are working with drones and suppose you are working in a hostile environment where there are like terrorists occupying a hill kind of area, and suppose you don't have satellite imagery, and then how do you deploy like a swarm of drones and coordinate localization among them?
All right. Who would like to go first?
I'm having a hard time understanding the second question. So you're saying if you don't have maps or a good model of the terrain of an area,
Yes.
how can you deploy drones?
Yes, you don't have, like say they are inside bunkers or something, you don't have satellite imagery which can give you the precise location or something, but then you can have like micro drones which you can deploy, and they need to communicate among themselves and fix on the localization.
Yeah, we're certainly doing stuff with autonomous swarms of drones at BBN as well. There's I think on our website recently we had some publicly released stuff about some pretty cool field experiments that we did. Yeah, so obviously maybe I'm not seeing the issue, but clearly having a map of the terrain and modeling the terrain would help. But we've also been doing some things, for example, of you can very sort of quickly stitch together models of terrain. We did a project where we were stitching together models of terrain captured by cameras of people parachuting out of planes. And so if you have multiple people that have parachuted out of a plane, and you can construct a model of the terrain that they're jumping into from those models, then you could send drones there. And similarly, you could just send drones in advance and scout the area, and if they can have some ability to avoid things and create models.
Do you want to add something on the first part?
What is the first question again?
Techniques from NLP into computer vision.
Okay.
I can jump in.
Yeah, I think that's what you just said, so you should go for it.
More
Yeah.
in this area, like.
Yeah, so I think that the traffic's gone both ways. So initially there were a lot of techniques from computer vision that made it into NLP. So CNNs and so on. And then now recently we're seeing transformer models being used initially in language, but then transferring to computer vision. And I think the guy, I was in the next session, the session next door earlier, and the guy was a brain scientist and pointing out, well, maybe these actually work well because they're all based essentially on how the brain works, and since the brain does both of these things, it's not really a surprise that there's kind of the ability to transfer from one to the other. But who knows what the next models will be and what they'll be inspired from.
Yeah. For drone stuff, look up Army Research Lab, Micro Autonomous Systems and Technologies. It's a program over a decade ago, and I used to work on that, so can talk later more in there.
Also, just to add that it's not only the computer vision strategy. When you do this comprehensive process to scope the university's location, it's also geointelligence. So you pretty much build that all blind spot to that planning and strategy to attack that.
Yeah, I think what you're alluding to and what you said for everyone's benefit, right? You're alluding to data fusion, where you're saying just having satellite imagery, even if it's occluded because your targets are inside, it still helps as you build that pipeline out of data to know exactly how you can localize, and all of that helps, right? Especially if you're in a GPS denied environment. So absolutely, happy to talk separately. I know this is a little bit off topic. So, and we're also at time. So what I would ask our guest is to please give some closing remarks. And just to help in sort of the focus area is, what is one takeaway for whether you're a startup or a big company, right? You need to make a business case when you say, hey, I need to go and build CV models or ML pipelines or things like that. And it's, I'm assuming there's a problem you're trying to solve. But in order for you to still make a business case, what's like one advice you can give everyone who's attending today? How do you approach that? How do you sort of bring that up, whether you're going to get funding or you're going to actually ask for funding from your company? How do you do that?
So I'd say two things. One, so if you're really interested in doing cutting-edge research, the government really is funding a lot of really interesting projects that don't have to be fieldable now, and we would love to partner with your startup. We partner with lots of startups, and we're also hiring, so come work on cool stuff with us.
Yeah, you're welcome.
And my current company, Fidelity, they encourage the people to have startup in mostly fintech, although it's not connected with computer vision, or maybe maybe computer vision, if computer vision can solve some of the problems, they will come. Fidelity hosts a lot of startup, I think 15 to 20 startup. They give their sales pitch every month. We sometimes we buy their product. Sometimes Fidelity, we have a Fidelity research unit. They spend quite a bit of money on startups.
So talk to him if you need funding for your startups, okay? Yeah. Or Raytheon, a great company you can work for. All right, let's give our guest a big hand and thank you.